Hey Zeldsmack, this is Erin McDermott. In this video we get to take a tour of the facility Makerspace. It's up in Linwood, Washington, which is just a short drive north of Seattle, Washington. This space and all its programs are funded by Edmonds Community College, but you don't need to be enrolled in the college to use the space or its facilities. The main goal behind this Makerspace was to make it very accessible to the general community. And they do this in a number of ways, one of which is it's really cheap and easy to get trained and ready to go on a machine. All you need is $50 and the training courses are 2 hours long and then you're ready to go. David Voteman gave us a tour and told us more about the different programs and offerings here at the facility.
We end up with this room first, which is our Composites Lab. It's become now kind of known as our Polymers Lab. We do a lot of plastics work in here. So you'll see, coming out of the ceiling, there are vacuum hoses. Like, if you come over here and you look at a vacuum bag, right? The vacuum bag, you've got two thin sheets of vacuum bagging material. It's flexible and durable. You've got a tool in the center. You infuse it with resin. So it's a really kind of super high-tech way of creating things.
What is this when it's all?
So this by itself, it's a student project. So I think they're probably making like a picture frame or something. Mm-hmm. So yeah, you make a tool, you make a form first. So say for example, you wanted to make a composite fish. You wanted to make a carbon fiber fish.
Who wouldn't want that?
Yeah, right. Everybody wants that. So you would create your tooling. In this case, that we've just thermoformed over an existing model. Right. Somebody cut out this whatever it is, this fish. So if you want to reproduce that in composites, right, you can turn that into a negative just by flipping it over. You'd lay up on the inside. You probably want to create make the back side of it a little bit more rigid, but you would lay up on the inside. And then you apply the suction, and it pulls this bagging material. It's like think of it like a fancy food saver, right? If you ever used a food saver, it's exactly the same thing. You're just going to pull all the air out of this, and when you pull out the air out of this shape, it's going to press against it, and you're going to end up with that imprint.
What kind of materials do you? This is like fabric.
So this is all. This is just fiberglass composites. So this is kind of an engineering grade composite. Typically when we get into longer, stronger fibers like carbon composite, we call them advanced composites. So if you come over here, this is carbon fiber. If you go into like a higher tech composite like this is actually a pre-impregnated tape. But to get that to kick off and liquefy, you have to put it in an oven.
And that's what you got over there?
So the silver is an oven, so you can kick off that cross-linking in an oven. Mm-hmm. If you want to go super high-tech, like you would if you're headed into Boeing, you would go all the way to an autoclave. So this kind of torpedo-looking, submarine-looking thing is an autoclave. And what the autoclave will do is, it has vacuum hoses in it. You can come take a look. It has vacuum hoses in it, so we can pull 3 bags. So there's one that monitors the vacuum in the bag to make sure that it stays at a particular vacuum. Mm-hmm. And then there's the other hose that comes out and actually pulls the vacuum, and there's 3 sets. Right? So we can pull 3 bags. The autoclave also brings it up to temperature, also pressurizes it, and the green device on the wall is a nitrogen generator. And so all of the oxygen is pulled out and it's replaced with nitrogen, so it's an inert environment. Right? We have this little injection molder, we have this little blow molder. We have an industry standard injection molder here. We also have rotomolder, right? So if you want hollow objects. We have a kind of a plate molder, so this is, what you need is temperature and pressure for composites, and so this just does that mechanically, right? The plates heat up and smashes things together. We actually upgraded the welding equipment a little bit, brought in tools like this horizontal bandsaw. We have a whole bunch of drill presses, bandsaws for metal and for wood. We have what I call the assembly floor. So if you're got a bunch of different parts and different materials and you need to assemble your final project, you can use our assembly tables. All of the assembly tables are full of tools. We call it our turret booth. It's just the manufacturer. So the air in this booth is evacuated through the 3 fans in the back. Composite technology is, I don't want to say toxic, that's not the right word. But if you get those fibers, if you get carbon dust in your lungs, it doesn't want to come out, right? So you really, really don't want to have dust in the air. So all of the air here is drawn out through filters, so it's a much nicer place to do dusty kind of operations. So again, initially for composites, but we put all of our super dusty equipment here, including our sandblaster, right? If you want to just do woodworking, right? So it's a great place to use our thickness sander. The deburrer puts off a little bit of dust. So basically all our dusty stuff goes back here. We've got a shear and a brake. The Cnc Router, it's a hugely popular piece of equipment at Makerspaces everywhere. Water jet cutter, so this just came in. Yeah, it looks like it's been used for years, but we've only had it up and running, I think, for maybe 3 months now.
A lot of use.
Yeah, so in theory we can cut, the manufacturer says we can cut up to like 6-inch plate steel with this.
Wow.
I don't see any reason that we would ever do that.
Have you tried?
We haven't.
Why not?
Yeah, well,
push the limits, David. See how?
Yeah, like I said, we're just getting up to speed. But what we have done is, we've cut a lot of stainless.
Ooh, that's neat.
So that is the Edmonds Community College logo on the top of a bottle opener. We've cut composites. That was one of the big things that this was brought in for. We've cut a bunch of plastic. We have like 3/4 inch thick piece of composite that we've cut perfectly. So, I mean, it does a really, really good job. There's classrooms in the back. So we have 2 fully mediated classrooms. I generally don't show people. We have a design lab. So that, we have 6 workstations that run SolidWorks.
Oh, nice.
We're just getting up. So if you know SolidWorks or Rhino, we have it here available for you. What we are officially supporting is Fusion 360 for reasons I'm sure you're aware of. Fusion does a very, very good job of what they do, and for people getting up to speed, it's inexpensive. We do have some welding equipment, so we have 2 of these household current, so just plug it into your wall. Again, if you learn on this piece of equipment, this is the same thing. You just plug into the wall in your garage and you're off and running.
Neat.
So we have 2 of these MIG rigs, so we're teaching MIG welding. If that gets really popular, we will eventually move into TIG as well, I hope. But MIG is a great way to start.
Great.
We've got a couple of kilns here behind our
What?
tent. So we've got a couple of kilns that we can run, obviously for ceramics.
Yeah.
It is set up right now to melt aluminum.
Whoa.
Right, so we can also do aluminum pours.
Neat.
So we can do foundry work. We do not have
Amazing.
a forge, so we can't do forge work, but we can do foundry work. So we have some destructive testing equipment for material testing. We have a Rockwell hardness tester. So for us, the TAS 6 is kind of the workhorse printer. They see most of the use, but we also have a U-print, right, for a little higher end printing jobs. It will always print in 2 materials, a support material and a model material. We also run 2 form labs in the back with the orange covers. We don't have a lot of the high tech. We're kind of new to them. They're super popular right now, both with us and kind of everywhere. We don't have a lot of the engineering materials yet, but we're looking into kind of experimenting with a little bit more form lab stuff. We do have 2 laser cutters. We have one that's multi-wavelength, so we can run fiber and CO2. We just got this one to run full-time CO2. We also, and I almost never show people this because this just doesn't make for good photographs, we also have 3D scanners.
Oh, cool.
That colleges have shops is not revolutionary. I think this is a pretty awesome shop for a college, but that colleges have shops is not the amazing thing. That those shops are available directly to the public is mind-blowing.
Yeah.
Right? That somebody can walk into this shop and in a very, very short amount of time get up to speed and work proficiently, I think is amazing. We're open Monday through Thursday from 5 to 9 now. We've just started kind of an expansion. So we're open Monday through Thursday, 5 to 9. We're open the second Saturday of every month. We're open from 10 to 4. All of this can expand within some boundaries. All of this can expand as those times get filled. As far as getting on equipment, in general, we have kind of an open shop policy. So as long as you're vetted to work on you've gone through that onboarding procedure, and that can be a checkout. So I've described the class, but if you already know how to work all the equipment in the wood shop, you can come in and in about 20 minutes, just do a checkout and prove that you know what you're talking about. So wood shop, metal shop would be a good example of where all that equipment is available on an open shop basis. So you come in, and right now it's just $5 an hour. Sign in. You can do that on our website in advance. You can do it here when you show up. You sign in, you use however many hours you need, you sign back out, you're good. Just $5
Is that just
an
for
hour.
the wood shop?
That's for so basically every tool that we have available here that you're checked out on. It's just open shop $5 cover charge.
What about materials?
So typically materials you'll bring in on 3D printers, the materials are included in the price of operating the equipment. So that covers a different category. A laser cutter is $30 an hour. We charge in 15-minute increments. So, you don't have to use up the whole hour. You can go for an hour and 15 minutes if you want. CNC Router is $30 an hour. Our base 3D printers are about $15 an hour. The one thing where I think prices are probably going to go down is 3D printer time.
Where can people go to find out more or sign up for things?
So, like I said, we just launched our website. Our website is facilitymade.com. So just go to facilitymade.com. We don't have a payment processor yet. It's something we're pushing very hard for. So, come in, you book whatever you want. We'll tabulate everything over a month, and you'll just get a paper invoice at the beginning of the next month, and everything's recorded for you. So it's a little like having a bar tab. You just have to pay it once a month.
Neat.
We're hoping to get that a little bit more streamlined. But yeah, go to Facility Made. It's a fairly straightforward site. You'll learn a little bit about the tools and the areas that we have. You can make any reservation. You can buy, if you make a reservation for the laser cutter, for example, in that checkout process, which again, you don't exchange money, but it is a checkout process, we'll make a suggestion that, you might need birch. Right? A lot of people come in and cut, Baltic birch. So you can add that to your order, and it'll all tabulate. It's all pre-cut, so it fits on our machines.
Nice.
All right, so that's one of those places where we do supply material. Like I said, the 3D printers, all of that, the material's just in the reservation cost.
Cool. So, that's great. Thanks so much. Appreciate your time.
For more information on the Facility Makerspace, you can check out the full article on solidsmack.com.